Welcome to tonight's video on method 3 of finding a limit, and that is multiplying by 1 over n to the highest power with the limit theorems. So the first thing we're going to do is identify what is the highest power of n, and in this case the highest power of n is 3. So we're going to multiply the numerator and the denominator by 1 over n to the third. And this technique only works when you have a rational expression. So keep that in mind. So now we have the limit as n approaches infinity of 4 over n minus 5 plus 7 over n to the third divided by 2 minus 1 over n to the third. So now we can apply the limit rules. And the limit rules here say that we can make this fraction, the quotient rule says that you can take the limit of the numerator, which is 4 over n minus 5 plus 7 over n to the third, over the limit as n approaches infinity of the denominator. Then the sum and difference rule says that you can take the limit of each term individually. So the limit as n approaches infinity of 4 over n minus the limit as n approaches infinity of 5 plus the limit as n approaches infinity of 7 over n to the third divided by the limit as n approaches infinity of 2 minus the limit as n approaches infinity of 1 over n to the third. All right, so now we've separated them. Now remember, our goal with is to either get the limit of a constant or the limit of n goes into infinity of 1 over n to the highest power. Because remember from the limit rules, the last two, the harmonic sequence, that's equal to 0. And the constant rule is the limit of that is equal to the constant. So if we could get these all to be 1 over n to some power or a constant, we'd be good. Well, to get this one, there is a rule that says if you're multiplying by a constant, you can move that constant to the front because it's like multiplying the limit by that constant. So 4 times the limit as n approaches infinity of 1 over n minus the limit as n approaches infinity of 5 plus 7 times the limit as n approaches infinity of 1 over n to the third over the limit as n approaches infinity of 2 minus the limit as n approaches infinity of 1 over n to the third. Now we've done that. We've gotten them all to be 1 over n to a power or a constant. So this is 4 times, well, the limit as n approaches infinity of 1 over n is 0, minus 5 plus 7 times 0, all over 2 minus 0. So this is equal to negative 5 halves. All right, let's try again with the next one. And then I'll let you do some on your own, and then I'll just post the answers. For this one, it's the limit. So first of all, the highest power of n is to the third. So let's multiply by 1 over n to the third, numerator and denominator. So it's the limit as n approaches infinity of 4 over n to the third minus pi over 1 over n squared minus 6 plus 1 over n to the third equals. So now we can split it up into the limit as n approaches infinity of 4 over n to the third minus pi divided by the limit as n approaches infinity of 1 over n squared minus 6 plus 1 over n to the third equals, and now we can take the limit of each term individually. N approaches infinity of 4 over n to the third minus the limit as n approaches infinity of pi over the limit as n approaches infinity of 1 over n squared minus the limit as n approaches infinity of 6 plus the limit as n approaches infinity of 1 over n to the third. And then we want to make them, to get the constants to the front, the only one is the one at the top. So it's equal to 4 times the limit as n approaches infinity of 1 over n to the third minus the limit as n approaches infinity of pi over limit as n approaches infinity of 1 over n squared minus the limit as n approaches infinity of 6 plus the limit as n approaches infinity of 1 over n to the third. And then you can take the limits, so it's 4 times 0 minus pi over 0 minus 6 plus 0. So it's equal to negative pi over negative 6, which is equal to pi over 6. So that is your limit there. So go ahead and look at the next page and go ahead and try those. I will then post the answers so that you can look at them after you've done them, because it's basically the same process. All right, so if you look at the next one, the limit rules are applied out here, and at the end you get 0 over 2 equals 0. Notice the first thing you do is multiply by 1 over n to the fourth, and then you apply all the limit rules. So if you need to pause it to look at it. I'm going to go on to the next one, which is part D. And with that, you multiply by 1 over n to the third, apply the limit rules, and then notice at the end you get 8 over 0, which is undefined, which is infinite, which means it does not exist because of unbounded behavior. All right, so then the next one, the first thing I would do is multiply these two together. All right, so when you multiply them, you get one fraction. And then you multiply by 1 over n to the fifth, and that gives you this here in green. And then when you take the limit of the numerator, divide by the limit of the denominator, and then you split them up into each individual terms, and then you factor, basically move the constants to the front for all the fractions, and then you find the limits. So notice it's equal to 8/3. And you're going to do the same thing for the next one, where I would multiply. Now for the next one, you can just multiply by 1 over n to the third. Or actually, yeah, you actually don't need to multiply because it's already in fractions. So basically you can just take the limit of each term separately and then multiply out the constants. and then you get negative 12. Next thing we're going to talk about are some basic arithmetic with infinity and zero, like the infinite rules. Now remember, p is in the real numbers, but remember, infinity is not a real number. All right, it doesn't exist in reals. Okay, but the number p does, and p is positive. All right, so 0 over p is just going to be 0. 0 over the opposite of p is also 0. Because 0 divided by any real number is going to be 0. P divided by infinity. Well, whenever you divide a number by something that's really large, it's going to be 0. Because this fraction is going to get smaller and smaller because the infinite part is going to get bigger and bigger. Same with negative p over infinity. Infinity to the p power is infinite. Infinity to the negative p power, this is where you gotta be careful, it's 1 over infinity to the p, which is 0. P over 0, that is infinite. It actually could be plus or minus infinity depending upon what the p is, and the same thing here, it's infinite. It's actually negative infinity, but it could be plus or minus depending upon what the p value is. Infinity over p is infinite. Same with infinity over negative p is negative infinity. P times infinity, well, that is just infinity. Negative p times infinity is negative infinity. P plus infinity is infinity. P minus infinity, that would be negative infinity. Infinity plus p is infinity. Infinity minus p, that's infinite. Infinity plus infinity is infinite. Infinity times infinity is infinite. Infinity to the infinity is infinite. Infinity plus 0 is infinity. 0 times 0, that is 0. But 0 times any number is 0. P to the infinite power, well, it's 0 if p is between 0 and 1. It's 1 if p is equal to 1. And it's infinite if p is greater than 1. So those are some of the rules of multiplying by infinity. There are also some what are we call indeterminate forms, meaning we can't determine what the outcome will be. And remember, infinity is not a real number, so the rules for real numbers do not apply to infinity. Negative p to the infinite power. Remember, if it's a negative number to a power, it can alternate between positive and negative. That's indeterminate. Plus or minus infinity over plus or minus infinity. Remember, infinity over infinity is infinite, right? It's indeterminate. When we say indeterminate, it means infinite. So the same thing. This is what it's called indeterminate. 0 times plus or minus infinity, that is also indeterminate.